Hey, good evening, guys. I do hope that you're doing great. And in today's video, we'll be looking into the very basic concept of chemistry, that is one of the atomic models, that is Rutherford atomic model. Hmm. So, uh, you know, what do I see is that we are unable to understand these concepts, right? We get stuck into it, and we just get confused in how many models are there, how we are you are unable to make a concept or a story. We'll be looking into making a story, like we'll be going to into a sequence so that you can understand. First of all, before starting this topic, let me tell you a bit about the history. So very first, what happened was that, as we all have studied, that the very first, let me zoom in on the very first point. What happened was, there was uh, John Dalton, scientist. What he did was that he gave the he said that okay, we can say Dalton atomic model. So what he said was atom is indivisible, right? So according to him, uh, atom is indivisible. There was no any sort of subparticles according to him, and that would be something very simple, like uh, atom is indivisible. These are atoms, right? These are the smallest particle that are indivisible. So these are something that matter consists of, and they are not divisible. Like we cannot study this furthermore. This was the very first statement given. Okay, so number two, the scientist came, uh, was J. Thomson. Right? What did he give was the plum pudding model. Okay, that is a quite simple model. What he did was that he said that there is a dish, uh, kind of a dish, uh, like plum pudding model. You can take it as custard or something like that. Like this is a dish, and we have got we have got this electrons. You can say these are the peanuts all around over here. These are peanuts. Okay, so let me draw here. Leave it. Okay, so according to him, the all this space is the proton, or the positive space. Something positive is there, and between these positive charges there lies very few electrons. They are just randomly arranged, as like we have got peanuts in a dish. uh, electrons electrons, right? So this was the J.J. Thomson model. Now what happened was that we got discovered the electron, proton and neutron, and after those discoveries a new scientist came, presenting his own uh, model, that was Rutherford. Okay, what did he said was he alpha did alpha scattering experiment. Okay, so in order to understand what he did was, we need to go into uh, the experiment which he performed. So let's get into it. And this was around in the 1910 somewhere. What he did was, like, this is a kind of a very thin gold foil. This is a gold foil, and uh, we have got this. We've got this. Wait, right, perfectly. Got this. And what we did, alpha scattering. We did bombarding of alpha particles that are positively charged, like the helium nucleus. So these are alpha particles. Alpha particles. We, we are scattering over here, and for suppose what happened was that, like this, this, this. So what happened was, it was observed, there were few observation when this got happened, like we got, some were going straight, some were deflected a bit, like this, and some got reflected even though in the backward, opposite paths. And let me tell you a thing, that this is the photographic plate, right? So this is the photographic plate that you're looking into. This is the photographic plate. This got, we got some sort of spots when light is spotted on it. So we've got spots over here, here, and here. So from this, he made some conclusions. He just, uh, after seeing this, he gave his model that electron arrangement is something like this. Let me show you. This is a kind of positive charge, and this is the electron. This being very bad. Let me draw it more perfectly. Okay, so this was something he did. He said this is the electron motion. It is just revolving in a spiral motion. It is spinning in orbital, or orbital round orbit form. So this is electron. This is spinning something like that. Like let me make the arrows, and he just said that this is happening. And what he gave the reason behind these reflections, let me make it more clear, looking into deep into it. So this was the gold foil atoms, like this was gold foil atoms. This was the first atom, this was the second atom, this was the third atom, this was the fourth atom. Like, we did got positive charges according to his model. So here would be any positive charge, here would be any positive charge, here would be any positive charge. Okay, these are atoms like this, 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 and this. So what happened is that, according to him, this is the enlargement of the gold foil, right? This is the enlargement of this gold foil. Okay, let me don't draw it with a blue, to it will make confuse you. So this is the enlargement of the gold foil. This is a gold foil, and what is happening inside it, we are just looking into the deep concepts, so give it a focus. uh, the one which traveled straight, like let me draw this one with blue, the one which traveled straight, like uh, this got traveled straight, and this got traveled straight, and one which passed very nearly the positive. Alpha particles are positively charged, right? They are positively charged, and we have got deflection, there is a repulsion between the similar charges. So there was no any positive charge, so it just went straight. And this is the reasoning which Rutherford gave. He just uh, said people this is happening, and he really looking into postulates as well in a formal way. But this is a story. uh, like this is the deflection. Once alpha particle went very closer to the positive nucleus, so that got deflected a bit, like we have seen. And in the case when just got directly hit to the atom, so it got reflected back. So this is actually happening inside that. So looking into the postulates, we've got the postulate as postulates. mm, so the very first postulate was uh, positive nucleus present. So there's a kind of positive nucleus present in an atom structure, and we have seen this. He just gave that the deflection or the uh, the the reason why the alpha particles didn't got straight. So the reason behind that is that there is a positive charge that is repelling the alpha particles that are being bombarded. So the second reason or the second postulate that he gave was that uh, negatively charged portions which surround nucleus called extranuclear part. Okay, so this means that uh, electrons electrons negative charge, to understand that a negative charge are, let me draw a smaller one. Okay, leave it. Electron uh, have got spiral orbital. Okay, you can say that spiral revolving motion. Okay, there are of course defects in this model, and we're looking into these as well, because if we take the today's modern age theories, they are totally unacceptable. The way which is saying that we have got electron that is having a spiral motion. This is a spiral motion. I've seen you guys that the green one, it is revolving with a spiral motion. So this is what he said. And three postulate which we have got is uh, electron. He said that electron is equal to proton. That was some kind of a thing that he said, but actually, uh, this also get disturbed in many cases. But he just said that even it is somewhere applicable in today's concept as well. The next part is uh, we have done with the major concepts. I do hope that we are done with it, and uh, there was nothing else. The major discovery that we do look into is this: the positive nucleus present. In other words, we also say that Rutherford biggest contribution that he discovered the nucleus. He discovered the positive nucleus. Even though there are some mistakes into that, but we got into the concept of nucleus. We got that there is a positive charge in the center of the atom, and that is kind of true and accepted till today. So that is have gone. We have got importance for that. Let's revise what we have done today. We will be looking into the defects of Rutherford atomic model in the next video hopefully. And Rutherford atomic model, let me sum this up. So we did looked into this topic, right? So there had been time we looking into history. The time came when atom is indivisible. There was no kind of subatomic particles. We are, if the atom is indivisible, how we can look into its structure? We just gave simple like this is. But when we get know about the subatomic particles, then we need to arrange the subatomic particles, and for that, Rutherford did an effort, and Joseph also did, but the plum pudding model, but that was kind of not acceptable. So he just said that this is a dish and these are electrons, and these are uh, randomly present, and that was kind of nonsense thing, right? So the next came the Rutherford. He did alpha scattering. That means he bombarded the alpha particles positively charged. Like over here, you can see that he just bombarded that on a uh, thin gold foil. I need to get you know that the gold foil is really thick, and that is um, happening is the inner structure of the what is happening on the atomic structure in the gold foil is this. Like you have seen that the one which are going straight. Okay, so the one which are going straight, this one we have got these, this one. Okay, so this one, uh, which are not facing any sort of disruption. The Rutherford atomic model also said in point. Let I got remembered that uh, for atom has a large empty space. Empty space. So uh, yes, of course, because according to him, there was a some kind of position that the rays got, majorly the rays went straight, and the reason behind going straight was there was a major portion that was empty and letting the rays to pass straight. So the next thing was the a bit of deflecting. So that was when we have got a near touch of the positive charges, and we have faced a repulsion like the hair, and we've got here. The other case was that got directly deflected by, you know, or it was to the point short of alpha particles on the positive nucleus. So what he did was he discovered the nucleus, like this part he got discovered. He discovered, and this is a major thing he discovered, and that is why we are studying this model even. So moving forward, we have got that he had said that electrons have spiral motion, even though that is not we cannot accept that, because if it is having spiral motion, the atom shall destroy after leaving its energy. He also said a point that if electron is having uh, this was a conceptual point that Bexel was a scientist. We'll be looking into the next video into it more deeply, but let me give you a overview of it. That Maxwell was a scientist who gave the electromagnetic theory. He stated that electron or any charged particle, if it is having a spiral motion, so energy would be emitted by it. So if energy is emitted by this electron, the atom will gonna destroy. So how is this acceptable? But we need to go into it, and he said that electron number is equal to proton, and we have got an empty space. And I do hope that this got cleared, and in the next video we're looking into uh, the the defects of it, and uh, we will be making a story and understanding it all. So meet you guys in the next video. For that, goodbye.